Today is Friday, March the 23rd, and we have the crowbar, the first of the crowbars for GE Australia, GE International. This particular board is ready to go, and what I'm going to do is I'm going to go through the setup. Then on subsequent videos, we're going to do the manual crowbar, the autonomous crowbar. We're going to simulate power loss, and then we're also going to look at the firing signal when we lose the 120 just by looking at the firing signal. The very first thing I want to point out is that yes, it seems like this is the standard crowbar and this is a crowbar. On a standard crowbar for a different customer, the AC gets rectified, and here you have the most positive. That's why the most positive gets connected to the anode of the SCR, the crowbar and SCR. The most negative will be called negative. There was a question here as far as what to call them. The way we're doing it here, we're bringing in the positive into what we call negative. So I'll discuss with you, but it seems evident that we're going to have to change this to bus bars so that we don't do this. This is our positive. Right now we're going from the positive to the negative. We want to change that so that the anode is on the positive, as pointed out. The same thing with the negative, which is connected to the negative of our diode rectifier. So let me just go through the setup. Here's the crowbar. So as I pointed out, this is where we're bringing positive DC and negative DC, and the way we are obtaining that is we have a variac, we have high voltage transformer where we can go all the way up to the 1450 volts. Well, that's AC. We're taking a pair of diodes, so we're taking the AC, we're rectifying that. The output of the positive again goes to what right now it's labeled negative, but we're going to change this. So this will be the positive, and then here we have the negative, and the way that it's connected is we are going we have our load, which is right here. We're taking it from the positive. Well, it's the way we have it here. It's just connected. Let me see. We take the load going through one side of the diode, from the positive to one side of the inductor. It's coming out of the inductor, and then it's going into this resistor load, and then the output of that resistor load, it's coming back, and it's coming back to the white to close the loop on the negative of the rectifying diode. It's basically going through here. The unit will be powered with 120 volts. Here we have that relay. It's labeled K2. That will, once we have 120, will close so that we have the 24 volts command. This will be closed and nothing will happen. It's only until this is broken that this if this is broken, if this is removed, the unit will crowbar, but this will stay on just because the 120 it's there. This relay will come in handy, as proven before. When we lose the 120, this will open and it will immediately remove the 24 volt AC command. What we've done, so that's the 120 powering the boards, and then the 24 volt crowbar command. We have this relay added for when we lose the 120, and here we have the 24 volts DC with its associated return, which could be the same 24 volts here. However, we wanted to make sure that this was independent, just because it's going to provide you a status of whether the unit is crowbar. And this, according to note 3, according to the requested logic, that relay, it's normally closed and it will open when the unit crowbars. And here we have a chassis now. So again, it'll be just a matter of discussing whether we need to change this, but the bottom line is that when the AC, the high voltage AC, is rectified, we have a positive, and right now the positive, it's going to the what we call the negative, which turns out to be the anode. So the positive, it's going to what we're calling right now negative, which we will change to positive, but ultimately it's connected to the anode of the SCR. So that's the only concern. We can change that because we don't have this. The anode will be connected to the positive automatically, but that's for somebody else. So we can make that change. I already pointed out that the two bus bars are symmetrical, so it's just a matter of placing one on the other with the corresponding connections. I also want to point out that we had to connect this, I think it's a 3-meter long wire that was connected to the positive when we had to bring it over to the anode, and that's where this is a 3-meter long wire that it's connected temporarily to the anode. So this is the setup. We're gonna end this video and we're gonna start showing the manual and the auto Crowbar. One thing I want to point out is that on the latest version of this schematic, we have a table here showing how to configure for different thresholds depending on how many jumpers are installed. For instance, right now the unit has these 2 jumpers out, and then we have 3 jumpers out on the side edge. So that will be 650. You have 3 jumpers for the side edge out, and the last 2 are for the diodes. Here they are 1 through 7, 8, and 9. So that it's corresponding to 2, 4, 6, 625, and 650. 2, 4, 6, 625, and 650. The other ones are shorted out. This is the end of this video.